So we are continuing Unit 11, Circles, today with Day 5, which is Other Angles of a Circle. We've talked about central angles, and we've talked about inscribed angles, and angles formed with a tangent. Now we're going to look at angles formed within a circle that are not at the center, using secants and chords. So the first thing we're looking at is two angles formed by two intersecting chords. So if you have any lines going across the circle here making an angle that is not at the center, the formula for it is going to be 1/2 the sum of the two arcs that it intersects. So in this case, it will be arc AB, and then adding arc DC to that. So you're going to take the two arcs, add them together, and cut it in half. So looking at a couple of examples here, the first one, we are looking for X, which is our angle right here. Well, the arcs that intersects are here and here. So to find angle X, we are going to do 1/2 the sum of those two angles. So 150 plus 80. And when you put that into your calculator, 150 plus 80 gives you 230. And we're taking half of that. So you'll end up with 115 degrees as our angle there. Now this can get a little more involved when you're looking for one of the arcs. So the second problem here is having us find arc CA. The easiest way I've found to do this is to put things into that formula. So we know that our angle measure, which is 160 degrees, is going to equal half the sum of the arcs. So that's going to be X plus the other arc over here, 240. If I distribute that 1/2, I end up with 160 equals 1/2 X plus 120. And then I solve this like an equation. So I'm going to subtract my 120. And then I'm going to multiply by 2 or divide by 1/2 to get my X equals 80 degrees. So that arc measure would be 80 degrees. We are going to skip the next two here. Actually, why don't you pause the video and try the next two on your own, and we will go through the answers in just a second. Okay, so looking at the next one, you'd set up the equation that our angle X equals 1/2 98 plus 82. And when you finish solving that, you'll get X equals 90. For the second one, when you set that up, you're going to have 112 equals 1/2 the sum of the two arcs. So in this case, X plus 92. So when you distribute your 1/2 and finish solving that, you actually should get an angle measure of an arc measure of 132 degrees. The second set of angles we're going to look at are angles formed by two secants or two tangents. So anything going outside of the circle now. And the formula for all three of these scenarios, either two secants, a secant and a tangent, or two tangents, is going to be the same. It's going to be 1/2 the difference of the two arcs. So in this case, it's going to be the angle measure equals 1/2 the big arc minus the little arc. So for the first one, you would do CB minus DE. For the second one, you would do CD minus DB. And for the third one, this does end up being the whole circle, but you would do CDB minus BC. So you take the big arc, subtract the little one, and cut it in half. That is probably the most complicated formula we are going to get to for this unit. So let's look at a couple of examples. This first one, we want to find the measure of the arc, which is x. So again, the easiest way I found to do this is start by saying, okay, my angle measure is going to equal half, and now it's going to be the difference of the two arcs. So I know that my big arc here is going to be 100, and I need to subtract my smaller arc, which is right here. Well, they didn't give us that, so I'm going to have to do 360 minus 90 minus 100 minus 120 to get that last arc. So I would subtract everything from 360, and I will end up with an arc measure up here of 50. So when I plug that in, I'm now taking half of 50, so my angle measure will be 25 degrees. The second one follows the same formula, but it looks a little bit different. In this case, we need to look at arc HTA, this big arc on the outside, and then look at our small arc as this piece right here. So again, we're going to have to do 360 minus 210, and that will give us 150 degrees for our small arc. So using our formula, x equals 1/2, it'll be 210 minus 150. Finishing that down, we'll end up with 1/2 of 60. So our angle measure here is going to be 30 degrees. The final problem is a little more complicated only because we are looking for our small arc measure here. And they give us the big arc measure and the angle. So using our formula, we can say that 100, which is our angle measure, equals 1/2 the big arc, which is 250, minus our small arc, which is going to be x. Again, we're going to distribute. So 100 equals 125 minus 1/2 x, and then finish solving this like a normal problem. So we'll have negative 25 when we subtract that over, equals negative 1/2 x. Divide, and we will end up with x equals 50 degrees. So again, those are a little more involved, but if you take your time and plug into what you know the formula to be, you'll be able to solve them without too much trouble. The next problem I'd like to look at is jumping to number 4, which is the bottom of page 21 in your notes. It says intersecting tangents MH and MA are drawn from an external point M in such a way that the minor arcs create a 2:7 ratio. Find the measure of the angle formed at the intersection of the two tangents. So we're starting with our circle here, and it says we have two tangents drawn to a point outside, which is point M. And one of these is going to be MH, the other one is going to be MA. Well, we know that our two arcs here are in a ratio of 2:7. So that means that 2x plus 7x gives you the whole circle, which is 360 degrees. That means 9x equals 360. And when we divide, we end up with x equals 40. To find our two arcs, we'll have 2x equals 80, and 7x equals 280. So our two arc measures now are going to be 80 and 280. And then we go ahead and plug into our formula. So our angle is going to equal 1/2 the big arc minus the small arc. And when you finish computing that, you should end up with an angle measure of 100 degrees. So my picture wasn't 100% accurate, but this angle is 100 degrees. The last question I'd like to go over is going to be number 5. And this one looks super complicated. So we're going to fill in what we know. We're going to use this ratio to find the other arc measures, and then we're going to end up finding the measure of angle F. So it starts off telling us that DAE is 67 degrees, and GCE, which point G is this one right here, GCE is 69 degrees. Well, using what we know about central angles and arcs, we can tell that this arc is 67, which is good because that's one of the two that we need to find angle F out here. The other one we need is going to be arc BC right here. Using this 69 degrees here, we know that this big angle, GDE, is going to be double that. So the big angle will be 138. And if we subtract our 67 away from that, it means that GD, the small arc right here, is 71. Now, using GD, DE, and then our ratio right here, we can actually figure out what the other three arcs are going to be. So I'm going to have 71 plus 67, and then I'm going to use my ratio, plus 3x plus 12x plus 5x equals 360 degrees. So that means that 20x plus 138 equals 360. I subtract. To get 222. I divide. And I end up with x equals 11. Now the important one that we were looking for, again, was BC, this one right here, which is actually going to be 12x. So 12x equals 133.2. And now that we have our big arc here and our little arc here, we can plug that into the formula, saying that angle F is going to be 1/2 133.2 minus 67. And if you put that whole thing into your calculator, figure out what it is, you'll actually end up with angle F equaling 33.1 degrees. Now, the next couple pages are a reference sheet for the different types of angles that there are in a circle. So take a second and try and fill that out. Once you've done that, there are some more problems you can work on in your notes. And your homework for tonight is going to be the Day 5 worksheet. So I hope that this has been helpful and that you have a spectacular day, and I will talk to you soon.